Today's lesson is going to cover inequalities in triangles. So there are a couple of things in section 5.5 that are important to know. Number one, you can tell which angles and side lengths are the largest and smallest in a triangle based off of the side lengths and the angle measures. So what I mean by that, anytime we're looking at a triangle, the largest angle and largest side are always across the triangle from each other. So in the first triangle shown here on the left, the angle up top here and this side on the bottom match together as largest angle and largest side. That will always happen in a triangle. Same thing if you look at the triangle on the right-hand side. The smallest angle and the shortest side are always across the triangle from each other. So, as long as you know all of the side lengths in a triangle, you can order the angles from largest to smallest, or vice versa. And the same thing, if you know all of the angles in a triangle, you can list the side lengths in order from largest to smallest, or vice versa. So in the first problem, I actually have these two directions flip-flopped, so I'm going to flip-flop them. I don't want to list the sides. I want to list the angles from smallest to largest. And then the second problem, we're going to list the sides from largest to smallest. All right, so if I want to go smallest to largest, I'm looking first. The smallest side is UV. And so the angle directly across from that would be the smallest angle, angle T. The next smallest side is the 8, and the angle directly across from that is angle V. So it would be the next smallest. And then the largest side is the 10, and the angle directly across from it is angle U. So what I've done here is listed the angles from from smallest to largest, because that's what the problem asked. And they would be angle T, angle V, angle U. And again, it's based off of the fact that the side lengths across from each angle are in order from 4 to 8 to 10. You can do the exact same thing with angle measures and then tell which sides are the largest and which ones are the smallest. This one wants the largest side to the smallest side. Well, the largest side is going to be across from the largest angle. So the 78 is the largest. The side directly across will be the longest side. That side length is DE. Then we would go to the next largest angle, which is 54. The side directly across from it would be the side length from E to F. And then the last one, smallest angle is 48. Directly across from that angle is the side length DF. So there are my side lengths listed from largest to smallest, completely based off of the fact that I can list the angles across from those side lengths from largest to smallest. And that's true in any triangle. That's why when you look at a right triangle, the hypotenuse is always the longest side. Because in any right triangle, the 90-degree angle is going to be the largest angle. So if that's the largest angle, that makes this out here the longest side. That's why the hypotenuse is always the C when we do Pythagorean theorem. So the next thing we're going to talk about is that anytime I have 3 side lengths, the only way that I can create a triangle is if 2 of the side lengths add up to be longer than the third side. That's the only way you can make a triangle. So if I add up 2 of the lengths, they have to be longer than the third side. Now, if I'm looking at these 3 problems down here, in order to figure out whether I can create a triangle, all I need to do is look at my 2 shortest sides, in this case 5 and 7. If I add 5 and 7 together, I get 12. 12 is not larger than 13, so that means there's no triangle that I can make. If I took pieces of string or toothpicks or rulers and made them 5 inches, 7 inches, and 13 inches, I wouldn't be able to connect them to make a closed triangle. So we go to the next problem. The 2 smallest sides are 6 and 9. If I add those up, I get 15. The third side's 12. 15 is larger than 12. That means that there is a triangle that I can create. If I took pieces of string that were 6 inches, 9 inches, and 12 inches long, I would be able to connect them and make a triangle. The last set, my two smallest sides are 10 and 15. If I add 10 and 15, I get 25. Now here becomes the question. Is that okay for it to be equal to the third side? The answer is no. It has to be greater than the third side. Even if it's just 0.1 greater, it has to be greater. So if I add up the two smallest sides and they equal the third side, I cannot make a triangle using those lengths. So in this last problem, no, there is not a triangle. Last set of problems down here says describe the possible length of the third side of these triangles. So either these two have to add together and then have to be larger than the third side, or those two have to be the difference for the third side. So the first thing you're going to do with these two numbers is you're going to subtract them and you're going to add them. If I subtract them, I get a value of 3. If I add them, I get a value of 15. What that means is my third side can be anything between 3 and 15. Now, that means I could have 4 as the third side length, or 5, or 6, or 7. I could go all the way up to 15. Now, here's the deal. Can I use 15 as a third side? The answer is no. Can I use 15 as the third side? The answer is no. It can be anything between 3 and 15. So 3.1 would work. 14.9 would work. But 3 would not. 15 would not. Same thing's going to be true over here. If I take those two numbers, the possible third side is first going to be the addition and subtraction. So 16 and 8. Which means that my third possible side could be anything between 8 and 16. So all you're doing is adding and subtracting the two side lengths given, and that will give you the range of values that your third side length can be. And again, it can be anything between those values. It can't be those values. 8 would not be an acceptable third side length. 16 would not be an acceptable third side length. Moving down, last two problems. Very similar to what we just did above. These are just ACT type problems. It says a triangle has two sides that have lengths of 8 and 14. Which length could not represent the length of the third side? Well, let's first figure out what could. Just like above, I'm going to add the numbers and subtract the numbers. So adding them gives me 22. Subtracting them gives me 6. That means my third length could be anything as long as it's between 6 and 22. So the problem is asking which one could not represent the third length. So if there are any numbers that don't fall between 6 and 22, that would be our answer. 7 is between, 13 is between, so is 18, so is 15. Your answer is D, because above we said that when you add the numbers together, it gives you the idea of what the largest possible length would be, but it couldn't be that actual value. It could be anything up to that value. That's why 22 is the one that would not be the answer. Number 9, which side is the longest? Well, in order to figure that out, we probably want to figure out what this third angle measure is. If I take 70 and 80 and add them together, you get 150. So this angle in here is 30 degrees. If I want the longest side, that means it's going to be across from the largest angle. Largest angle is 80. Longest side's directly across, which would be side length DE. Flipping over to the back, we're going to talk about another inequality type concept with triangles, and it is called the converse of Pythagorean theorem. Now, let's talk about what Pythagorean theorem says. Pythagorean theorem says, given a right triangle, like I just drew in purple, I can take the legs of the triangle, I can square them and add them, and it should equal the hypotenuse squared of the triangle. That's Pythagorean theorem. The converse is backwards. The converse, you don't know that you have a right triangle yet. You have to determine that with the converse. So what the converse can actually do is it not only can tell us whether or not we have a right triangle, but it can also tell us if a triangle is obtuse or acute. So how do I figure out which one it is? We are still going to do a squared, b squared, and c squared, but we're going to compare the results. If we figure out that c squared is equal to a squared plus b squared, that means that we have a right triangle. If we find out that c squared is larger than a squared plus b squared, then we have an obtuse triangle. If we find out that c squared is smaller than a squared plus b squared, then we have an acute triangle. So it's all about how the numbers work out. So if I'm asked whether these triangles are acute, right, or obtuse, the first thing you're going to do is identify, well, which length would be the C, because C is always the largest one. So in number 1, 20 is going to be my C. So what I'm going to do is I'm going to set it up just like this. And I would like you to set it up like this every time, please. 20 is C, so 20 squared. The other two lengths could be A and B in either order. So we're going to do 12 squared plus 16 squared. So what you're doing is you're figuring out what does each of these columns give me, and then we're going to compare the result. So in your calculator, if you do 20 squared, you're going to get 400. In your calculator, if you do 12 squared plus 16 squared, you're also going to get 400. So if we look above, since these values came out to be the exact same, c squared is equal to a squared plus b squared, the triangle above is a right triangle. Anytime we get these values to be equal, we have a right triangle. The next problem is not going to be a right triangle. So let's figure out what kind it is. So first thing, c squared by itself, a squared plus b squared together. Of the lengths, C is always the longest one, so 12 squared. A and B are always the two smallest, so 3 squared and 7 squared. When you do 12 squared, we get 144. 3 squared and 7 squared, 3 squared's 9. 7 squared's 49. So putting those together, we get a total of 58. Now notice, this is not a right triangle, because those two values didn't come out equal. So how do I figure out whether it's acute or obtuse? C squared in this case is larger than a squared plus b squared. Anytime c squared is larger, that makes this an obtuse triangle. If c squared were to have come out smaller, then we would have had an acute triangle instead. So all we're doing is the same thing every time, and then comparing the values at the end. All right, so next one. Notice that we have this square root thing up there. How am I supposed to determine which side is the longest one? Well, if I plug the square root of 35 into the calculator, it's going to tell me that the value is about 5.9. So if I'm trying to figure out which one is the longest side, obviously the square root of 35 is going to be the longest side. So I'm going to square that value as c squared, 4 squared and 5 squared as a and b, and we're again going to compare the values. Okay, now remember back to Algebra 1, and you probably talked about this last semester with your geometry teacher. Anytime you square a square root, the square and square root cancel out, and all you get is 35. 4 squared, 16. 5 squared is 25. If I add those together, I get 41. So, again, they're not equal, which means this is not a right triangle. However, we can classify this as an acute triangle because c squared is smaller than a squared plus b squared. So 35 smaller than 41 means that this is an acute triangle. In the next problem, we're going to continue to do the exact same thing. 8's the largest side, so that's going to be our c squared. 5, and 6 are our smallest, so they're going to go in for A and B. 8 squared is 64. 5 squared is 25. 6 squared is 36. Adding 25 and 36 together is going to give us a value of 61. So in this case, we run into the case where c squared is larger, which would then say that we have an obtuse triangle. 2 left. First thing I'm going to do in the next one is identify what the longest side is. It's 15. C squared is going to be 15 squared. A squared and B squared, 8 and 12 are the shortest, so they get squared and added. So again, this is all calculator. 15 squared is 225. 8 squared is 64. 12 squared is 144. Adding those together gives me a value of 208. So in comparison, this is obviously not a right triangle because the values are not equal. C squared is larger though, which makes this an obtuse triangle. Last one. Exact same process though. Last one. First thing, 17 is the largest side, so that by itself. 8 and 15 are the smallest sides, so them by themselves. We're going to do some squaring. First thing is 17 squared gives me 289. Squaring the 8 and 15 and then adding them together is going to give me a value of also 289. So in this case, each of them came out the exact same. Since they're equal, that means that this is in fact a right triangle. So, converse of Pythagorean theorem says compare the value of c squared, compare it with the value of a squared plus b squared. If they come out exactly the same, like in number 6, you have a right triangle. If c squared comes out larger, like in number 5, we have an obtuse triangle. If c squared comes out smaller, like it does in number 3, then we have an acute triangle. So you're going to have an activity in class that's going to give you some triangles, and it's going to ask you to classify whether they're acute, or they're obtuse, or they're right, and you have to show the math reasons on why you're making the statement. Because it looks like it is not an acceptable reason in geometry. Make note of any problems that you have questions on so that you can ask about them in class tomorrow.